as front-end developers, we very often get things like date strings, numbers, and lists from our backends or APIs, and those are all unformatted. So our backenders just send us a datetime string, and it's our job to make sure that they are appropriately shown to users. And when we think of formatting things, we usually don't think of that as an internationalization problem. Instead, we think that we have a date that we need to format. And so we reach for a specific library that does that. So these are all libraries that we commonly use to deal with dates, numbers, currencies, and the like. And all of these are pretty hefty. They're pretty large libraries to include in your site. Unfortunately, for a while, they were required to do anything useful with like date formatting or currency formatting or whatever. And the problem there is that we recognize some APIs and ignore others. If you look at the Intl API, which is the topic of this talk, you might have already looked at something called the datetime format API, because the name datetime format is pretty accurate. It describes what it does. But you might have ignored APIs like the collator or plural rules API because you weren't sure what they did. And getting to know these APIs means that when the need comes up, you already know the right tool for the job without installing anything from NPM. So you might be thinking, my site is only in one language. Why would I need internationalization? That's for like multiple languages. And of course, you wouldn't be the only person to think that. INTL is a pretty weird name on the surface. So the INTL API is actually a really powerful formatter, and it helps you format dates, numbers, including numbers with units, currencies, lists, and words in a way that is appropriate for your user's locale, for your user's language and location. And that's where the internationalization comes from. It's not that you need to support multiple languages, but you have one specific language that you want to format all this different type of data in. So INTL has been built into browsers and has been baseline widely available since 2017, which means that it's in all the browsers you use all the way from 2017. Because it's a browser API, it costs you nothing to implement. It costs you 0 download time. As I said, it's fully local aware, meaning it knows about the languages, but also about countries. And that's something we'll see may matter more than you now realize. And lastly, because it is built into the browser, it doesn't run on your JavaScript main thread. It runs on the browser's thread. So that makes it really, really fast. Now, I'm going to go over different types of data you might need to format and show you how the INTL API can help you with that. We'll look at dates and times, numbers and currencies, lists and text, segmentation, and collation. If you don't know what the word collation means, don't worry, neither do I, but I will be able to explain you the API. We'll start with dates and times. INTL offers 3 date-related functions: datetime format, relative time format, and duration format. So datetime format will let you format dates. That's pretty self-explanatory. Relative time format will let you format durations or distance between time. So things like in 3 days or yesterday. Whereas duration format will let you format durations, something like 2 hours, 5 minutes, and 30 seconds. So here's the simplest example of the datetime format API and indeed the INTL API itself. The way APIs in INTL work is that you create a new formatter using new INTL.whatever. And this new object has a format function. So we created a thing called formatter here, a const called formatter, and we can then call formatter.format with your data. And that format function will return either a formatted string, as we see here, or a result, which is an array-like object that we'll get to later. You can see here that it returns today's date in the format appropriate for my locale, which is Dutch in the Netherlands. But it's also pretty terse, and we can easily tell datetime format to format things differently. So the first thing we can do is tell Intl which locale we want to use. And here I've specified French. If you don't specify one, it will use the browser's locale. So whatever the user has set as their language. Here I'm specifying French, and you can see that the date is now formatted in a way that is appropriate for French speakers. I didn't have to know that mercredi is Wednesday. The browser has this information built in and just formats this date for me. Now, this second argument in the datetime format API is an options object where you can specify how you want this date to be formatted. You can be very granular and specify exactly what part you want to show, but in most cases, you can just use date style and time style to get a good default. So here I'm asking for a date style that is full, so that will use the day name and the month name, etc. But you can also have it fit into a medium or a short sentence, and then it will skip over those or use a shortened version of the week name and the month name. So to specify exactly the parts you want to show, you can also use these options, weekday, era, etc. For each part of the date, like weekday or month, you can specify how you want it to be shown. For example, month can be numeric, 2 digits, narrow, short, or long. So you can get exactly the format you want. If we take September, for example, numeric would be the number 9 because September is the 9th month. 2-digit would be 09 because 2-digit will make sure that there's always 2 digits so that each month is the same number of digits. Narrow would be the letter S, short would be Sep, and long would be September. So depending on your needs, the browser can figure out the ideal length for your date format. Now, if you have these options specified, like month and year, only the specified parts will be shown. So if you only specify year and month, you only get year and month in the output. So there are various different ways to set or not set the locale for your formatter. When you don't specify a locale, as in the first line, the API will use the browser's locale. You can also explicitly set it to default to get the same effect. So default will use the browser's locale. If you want to be explicit about it, you can set your own locale. So in this third example, I've set it to Hungarian. But you can also use the navigator.language and navigator.languages browser properties, which will either give you the primary language, so US English, or it will give you an array of the supported languages, sorted in order of the user's preference. So you can see here that navigator.languages is an array, and that is also supported. What this allows you to do is specify multiple different locales, and the browser will pick the first one it supports. Now, this is generally not something you have to care about, because all the major browsers all have support for over 7,000 different locales. So you really have to go out there to find one that isn't well supported. Moving over to relative time format. So that makes it easy to format a time relative to the current time. You can set the locale and options just as you did with the datetime formatter. And then you give it a number, which is positive for the future and negative for the past, and a unit. So a unit can be things like seconds, minutes, hours, days, weeks, months, quarters, or a year. And as you can see, if you set numeric to auto, then one day in the future will be tomorrow, or morgen in Dutch. Whereas -3 month will be 3 months ago. So the options you have here are numeric, which can be always or auto, and then always will always make sure to show the number. So instead of tomorrow, it will say in one day. And auto will switch over to things like tomorrow or yesterday when appropriate. So style can be long, short, or narrow, with the last two using shortened versions of the words. So instead of in one day, it will be in one letter D. Now, something that's annoying about relative time format is that it doesn't take a set date, but a number and a unit. So if you have a date, for example, the release date of a blog post, you need to calculate the difference between that date and now in the appropriate unit yourself. So since dates are milliseconds, you can subtract one from the other and then divide up to the unit you want. So there's 1,000 milliseconds in a second, there's 60 seconds in a minute, there's 60 minutes in an hour, and 24 hours in a day. Then you can round that to get a whole number and pass it into relative time format. And then you get in 2 days, in 3 days, tomorrow, etc. Lastly, duration format lets you format time durations. Again, you can call it with a locale and different options, where style is the one that sort of automatically takes care of everything. It lets you choose between long, short, and narrow, and digital. So digital is very useful when you want a digital clock output, like 00:45:30. So duration format will show all the parts that you specify in its format function. So if you only specify minutes, it will only show you minutes. If you specify minutes and hours, it will only show you minutes and hours, except when you set the style to digital. Because if you set the style to digital, it will always show hours, minutes, and seconds, because that's what a digital display shows you. In all other situations, you can always override the display of these things by setting it from auto to always. So those are the 3 date and time related formatters, and they're essentially the biggest part of the INTL library: formatting dates, formatting relative time, and formatting durations. But the numbers format API lets you format numbers in a way that is appropriate not just for the user's locale, but also for the type of number, the unit. You'll see it most often used for formatting currencies. And if you think that formatting currencies is just about putting the right currency symbol in front of the number, then you're in for a surprise. Here, I'm formatting the same number as euros in 4 different locales. So I have Dutch, English, French, and Arabic. And you can see that it's not just the placement of the euro sign that changes from the front of the string to the end of the string, but also the thousands and decimal separators change. So in Dutch, we use a comma for decimals, whereas in English, they use a dot for decimals. You can see how this can get really confusing really fast if you show the wrong thing to the wrong user. And you can also see minor changes, like for French, they generally don't put a space between the currency sign and the number, whereas we in the Netherlands do. This is all stuff that the browser knows about your locale, so you don't have to. And that saves you from confusing your user. Now, something that you don't see here is that the INTL API even uses non-breaking spaces for those spaces. And that makes sure that the currency sign never gets separated from the number, even if it falls across different lines. So that's really nice. Now, if we zoom into styling currencies, there are quite a few options you'll want to know. So the currency display option lets you choose how you want to show the currency. The default is symbol, which for US dollars is US dollar sign, to differentiate from things like Canadian dollars, Australian dollars, etc. Narrow symbol would be just the dollar sign. Code would be USD. And lastly, the name would be the currency spelled out, like American dollar, or if you use the Dutch locale, Amerikaanse dollar. The currency sign determines how negative numbers are shown. So by default, negative numbers are prefixed with a minus sign, which is how us normals do it. But if you are an accountant, then you don't like minus signs. I don't know why, but accountants, they prefer to put parentheses around the number. So if you set currency sign to accounting, then you get parentheses instead of a minus sign. Now, formatting regular numbers can be done by setting the style option to decimal, or omitting this option because decimal is the default. When formatting numbers, you can see that it adds a thousand separator and uses the appropriate decimal separator for the locale. So either dots or commas, depending on where you are in the world. There are much more options for formatting numbers, like specifying how many decimals to show or how many significant decimals to show, but we'll skip over those in the interest of time. By the time that you need that, you'll really want to dive into the specification itself. Now, there's the percent style, and that makes it easy to convert a fraction to a percentage. This is really simple to do by yourself, but the automatic formatting that the Intl API gives you helps you stay consistent. So there is even small difference here where French will have a space between the number and the percent sign, and the Dutch won't. So these are all small things that will improve the consistency of your text. And that brings us to the last number, or last number style, unit. And this lets you format numbers with a unit. So the list of supported units is really, really long. It includes things like length, mass, speed, time, temperature, digital size. And that means you can use things like kilometers, grams, years, Celsius. And it even has a neat trick up its sleeve, because you can write the unit as unit dash per dash unit to get things like grams per liter or kilometers per hour. And the browser also knows how to show or format these compound units in a locally aware way. So if I set kilometers per hour as the unit here, and I format it in Dutch, it will show me 6 km-u. Or I can set the unit display to long, and then it will become 6 kilometer per uur. So it will have all this in every language that you care about. So next up are lists and text. There are two formatters here: list format to format lists of things, and plural rules to help you deal with plurals or multiples in a local aware way. So when dealing with lists, you might be tempted to just do an array.join with a comma, but that's not how we make lists in natural language, because we'll do A, B, and C, or A, B, or C. So the list format API lets us make these lists in a more natural way. The type option will let you choose between conjunction, which is the and, or disjunction, which is the or, and then lastly, we also have the type of unit, which is just a comma separated list. And you'll want to use that for things like ingredient lists, because that doesn't require an or at the end. Now, the default value of this, if you don't set any type, is conjunction. And this makes it much easier to create natural language lists rather than like looping over an array and finding the second last one and then adding an or instead of a comma. So this makes it much easier to create natural language lists. Now, the plural rules API takes some time to wrap your head around. It doesn't format anything itself, but it helps you figure out which plural form to use. Here I'm creating plural rules for US English, then calling select with a number, and the return value of this is a string that tells me which plural form to use. So in English, there are two forms, one and other. One is used for the number one, while other is used for everything else, including zero. So you have one item, but two items or zero items. So by returning one or other, you know whether or not to add this last S to the word. Now, English has just two plural forms, so that's pretty easy. You could also do it with modulo, for example. But other languages have many more to differentiate between things like two of a thing and more than three of a thing. And this is where the plural rules API becomes much more useful to give you the appropriate information. Now let's move on to the segmenter API, which helps us to do something that's really easy for humans, but hard to do in code: segment natural language. If we look at the sentence here, it's easy to determine it has 7 words. And in code, we can just split on a space and also get to that 7. But that's only true for languages that use spaces to separate words, like English. But how many words are in this Japanese sentence? I have no idea. And I also know that splitting on spaces won't help. So here we're out of luck. But other things that sound easy are still hard to do in code due to the implementation of Unicode. So how long is this text, for example? As a human, looking at this, I would say 1. It's one single emoji. But in code, it's 11 character codes long because of the way Unicode works. And lastly, what about sentences? How many sentences are in this text? Again, as a human, it's very easy to see that there are 2. But if you do naive splitting on a dot, you get 3 because of the dot in the number 100,000. Now, let's go over all these examples with the Segmenter API, beginning with counting words. For English, our split trick worked fine, but with the Segmenter API, we can do this the correct way. We specify the language and set the granularity of the segmenter to words, so that it breaks the text string into words. This returns a result, which is an array-like object, and it has an object for each of the segments that it split. Each object has the value, so segment.value, which is things like how or a space or a question mark, and a property called isWordLike. And if we filter on that, we get just the words and can count that there are 7 of them. Japanese doesn't use spaces between words, so our split trick failed there. But the Segmenter API does know how to break Japanese text into words. So we get the correct number here, which is 6 words. I have no way of verifying this is actually correct, but I'll take the browser's word for it. Now we'll switch the granularity to grapheme, which means a user-perceived character. We already know the emoji here consists of 11 character codes, but the Segmenter API knows that it's actually one grapheme, one character as perceived by the user. And lastly, setting the granularity to sentence will break the text into sentences. Note that it correctly handles the period in the number 100,000 and doesn't mistake that for the end of a sentence. Now, unlike the word granularity option, there is no isSentence-like property. Everything it breaks the text into is a sentence. The last Intl API I want to tell you about is the collator API. So the collator API helps you sort strings in a local aware way. Sort of like array.sort, but better. If you look just at English words like apple, orange, and banana, if you call .sort, it will sort just like array.sort would normally do. But there are places where sort breaks. For example, in Spanish, the Spanish alphabet has the letter Ñ, the squiggly N. And in the Spanish alphabet, that squiggly N comes after the regular N and before the O. But in Unicode, that squiggly N is all the way at the end of the alphabet. So if you do an array.sort, the Ñ will be in the wrong place. But if you use the collator to compare, it knows that in Spanish, the Ñ sits between the N and the O. And this means that using the collator API to order things like an index makes sure that people find things in the order they expect. So this is what INTL gives you in every browser since 2017. So next time you need to format something, anything, measure something, or sort something, these are the APIs to reach for rather than NPM packages. So here's to making better websites. Thank you for listening.